So problem 10. What's the number of ways to color n objects with 3 colors if every color must be used at least once? So suppose we have 3 colors. It could be any color. Let's suppose these are red color, green color and blue color. So we want to color n objects with these colors. If we do not have any restriction, like we don't have restriction of that at least every color must be used at least once, and then in that case how many possible ways we have? For the first object we have choices of 3 colors, for the second object we have 3 choices, for the third color we have 3 choices, and so on. So we are going to have 3 raised per n. So but we have restriction that every color must be used at least once. So what we do is we subtract illegal ways. So illegal ways are if we are using only 2 colors or if we are using only 1 color. So suppose if we are finished with the blue color and we are going to use only R and G, red and green colors, then how many ways we have? 2 raised power n. In this case, be careful, we can use only red color also, and we can use only green color this case as well, or we can use RG both. Similarly for RB, in this case we can use red color or blue color, but we do not use green color, or in this case green color or blue color we can use, and we do not use red color. So these are illegal ways. So how many ways we have illegal ways? 3 multiplied by 2 raised power n. For each of this we have 2 raised power n ways. So there are 3 cases. So there are 3 into 2 raised power n ways. So we have to subtract this from all possible ways. But be aware that we count the ways also when we are coloring only single color. As I said that when we are choosing, for example, R and G, red and green, so we use red color, green color for n objects. So there could be that possibility when we are using only red color, or we are using only green color for all n objects. So we have to be careful for this thing. So we subtract illegal colors from this all possible colors. All possible colors are 3 raised per n, and we subtract these illegal ones 3 times 2 raised per n. But how about single colors that we have just discussed before? When we had subtracted RGB, subtracted illegal ways, so we have subtracted red, green and blue 2 times. When we are, for example, subtracting R and G, then we are subtracting R and B. So first R is subtracted here and R is subtracted again. Similarly, when we are subtracting GB and RG, so G is subtracted here and G is also subtracted here when we are using single colors. Similarly for the blue, blue is subtracted here and blue is again subtracted over here. So we have subtracted single colors 2 times. Red in this case, red in this case, green in this case, green in this case, blue in this case, blue in this case. So we have done over subtraction. So it means we have to add it back. We have subtracted more than needed. So it's not fair. To be fair, we should add it back 1 time because we have subtracted single color case 2 times. So number of ways to single color, for example, for all n objects, if we are going to color them in red color, so there is only one way, that all objects are color red. Similarly, if we are going to color them green, so all objects are colored in green, so there is only one way. And if we are going to color all objects into blue, so 1 raised to power n is equal to 1. So all objects are colored in the same color, there is only one way. So how many total ways are? 3 times 1 raised to power n, which is 3. So we have to add 3 back. So total ways are all possible ways to color 3 raised to power n minus illegal ways, which were 3 into 2 raised to power n. And we have to add back if we have subtracted something additional, which was like single color, we have subtracted it 2 times. So we have to add it back 1 time. Thank you.